Cosme Popin. Good afternoon, everyone. Brazil is, it's a pleasure to be here again at LACNIC, sharing knowledge. In this presentation, I don't want to dream that. Please do not think that you are going to leave this room as experts, but the idea with this presentation is to at least sow a seed, showing you how we need to debate VPN. We are going to debate the VPN. There are different solutions, different that are appearing in the networks, and we need the community to start understanding and to start at least practicing so they can start implementing it. The items that we are going to discuss, let me give you the context. We are going to motivate people and showing why we need eVPN. We're going to see the challenges of traditional VPN, so the technical benefits of an eVPN, and also options for evolution. We don't need to design a new network. We can implement the VPN in the current networks in phases, in stages, and to migrate without having a significant impact on networks that are already there. And we're going to talk about the future. What is it that we envisage for the future? What are the big problems facing our networks? When we speak of a backbone network today, we know that there are many that are trying to implement VPN. And so that of the year 2000, some are starting to learn what VPLS is to start implementing it, or some that already have VPLS. We realize that it's a protocol that is over 20 years old. At the time it was created, we didn't have the demands that we have today. One of the demands was expanding 5G, or the demand for migrating to the cloud of the apps. So, of course, the limitations of IPv4 are obvious. In most presentations, the speakers mentioned IPv6 and how beneficial it is to implement it. The traditional VPNs, as I said, VPLS, L3 VPN, are old protocols that did not anticipate some of the current needs, and they are not capable to adapt to meet the needs of current users. eVPN appeared as and got developed to unify the control plan. All eVPN runs on BGP, and it develops a separation of the data plan and between the control and the data planes. And why is it significant? Because it can be used with any underlying protocol, any sublayers. We are going to use eVPN of UCD1 over VXLAN, or through the VPLS in the segment route of VPLS, and several flavors of transport protocols will benefit of the control plan in eVPN. Here we have the challenges of traditional VPNs. One of the key challenges that we have in L2 VPN is having a single active or passive access. I cannot make the most of our capacity, of band capacity. I can't make full usage of it. It is very difficult for me to deploy the VPNs, the L2 VPNs, when I need to offer redundancy to the end user. So this is one of the flaws of L2 VPN. In the case of L3 VPN, these are fragmented protocols. The routing protocols are divided, and I have a limited integration with the cloud. I cannot implement an integrated protocol in the cloud where I'm going to implement my apps. In the case of the L2 VPNs, I have Mac learning based on broadcast, as in the internet. We have, with the implementation of flooding based learning, we are wasting a lot of band. We waste band, we waste the resources in our machines, and with the current networks, we see that those networks turn larger and larger, and they suffer more and more the impact of that type of approach. So, what are the benefits of the eVPN? More efficiency. With the eVPN, I can balance the load. I manage to control the BUM traffic to have redundancy with the access, all active access so that the loop won't get closed in that environment. So I can control the bomb traffic, the unicast and multicast, so I don't have flooding when I am working on an eVPN in layer 2. And why does it control that? Because it does the communication through BGP prefixes. I don't need to replicate the MAC tables anymore in the traditional way that we see in the current networks. It's simplified in the eVPNs. The discovery of peers is automatic through a BGP type 3 prefix. So the peers are announced the peers are announced to each other, and so they can have the and then we have the mesh with the eliminate the full mesh with route reflectors in a network with the eVPN. The network gets ready for a CDN network where the route reflector designs the structure, and the route reflector commands the topology. What will the topology of my network be? It is very important when designing the topology, and a much more rapid convergence. We can update routes in up to 50 milliseconds through BGP. There was if a link crashed, then it is announced the prefixes of VPN all together among the reflectors, and so that gets synchronized. It releases the max in the tables and does the synchronization and the restructuring of my environment. Comparing eVPN with against the traditional VPN. Well, I mentioned that in the case of eVPN, scalability is very high because of how easy it is for BGP route reflector, BGPRR. In the traditional VPN, we needed a full mesh. We needed to create to be careful with NBP SP so that it would be synchronized all the time, seeing whether it was active or not, and it ended up having less of a growth or less capacity for growth because of the excess of protocols issuing signals. We overloaded my control plan. The objective of VPN was to simplify the control plan so that it will use less resources from the routers, and enabling me to work in large-scale networks without having to work on the routers plan. In the So I have all the assets from P to CE. I can have it active or passive without having to worry about the loop with control through the BGP. The protocols are unified through BGP eVPN. The traditional one, there were multiple protocols. It was like an endless thing that you had to synchronize and unify, and so SBF would unify, and then the PE had to calculate. We had microloops activating synchronization between the two protocols. There were many concerns. So in the current networks, there's a lot of concern with the synchrony with the different protocols. eVPN comes to simplify the entire thing. Convergence is very fast because as I reduce absurdly the number of protocols that need to process convergence, I also increase the speed with which the convergence takes place. And there, as I mentioned, I have different options. In the case of evolution, I don't need to create a new network and to put together a parallel network to migrate my clients to that parallel network. So one of the migration forms is integration. And where is it that I use those migration methods? In the non-hierarchical networks, where that is what is more common for us to see in the ISPs in general, the networks that do not have that traditional PPEC, where everybody does PE and everybody has the different roles. So depending on the customer, my router is UP or will only do one passage or one swap. In non-hierarchical networks, I can do it like this. Some coexistence is gradual between the traditional VPN of any type and with VPLS and any others. How would this work with a VPN? An eVPN. We won't speak of vendors because each vendor implements it in a different way, but you're going to generate a virtual interface where in one direction you have the VPLS and in the other direction it will transform it into eVPN. So we're going to have a simplified communication in the network. And hence, we migrate from one node to the other. And for each PE, by each PE, as the network evolves, and the good thing is that there's no downtime. I can plan migrations without needing to have any downtimes in our clients' services. Now, in the part of internet working, here I have a hierarchical network. That network with the traditional VPN and the EP that provides services to the customer. In this case, I have to work with the border nodes, the stitching nodes. So there I can do the translation of this eVPN to the other. However, I'm going to have to structure the design, and I can also do it without having any interruptions in the network. No downtime, and I can plan the evolution of the network with no downtime. And what is that? What do we think that will be the future? Well, what do we see? What are the trends in our networks, the transmission networks? Unification of unicast and multicast, that is a unique control plan. I no longer lead separate control plans for the type of traffic for the eVPN and universal overlay. As I said at the beginning, it's very important for us to start understanding the eVPN because eVPN will do the control plan of almost all the transportation protocols. If I wish to work with a LAN network, well, that is replaced with the VXLAN, and the one that was prepared for the data centers, now it goes to the other networks and it occupies its place. The LAN network does an and who does the control of BGP, that is on top of that. So in the SV1, who does the addressing, who does the allocation, BGPN. It's the same, the eVPN that does it. When I speak of an operator network, transportation network, eVPN is being replaced by the segment routing, both in the VLPLS or in V6 or as V6. No matter which the plan is, this is going to be on top.
Even in a traditional MPLS network, I can use the VPN to see who delivers the service. What is the goal? This is an end-to-end network on SRv6. It's an end-to-end network on eVPN on SRv6. Here, eVPN will also make it possible to have a software that manages the network. This is what we expect regarding the software-defined networks. The software will command my network through the eVPN. I will have a management layer, the software layer, and below the route reflectors that are the control layer. And below these, what you prefer to use as regards the transport in order to do end-to-end delivery. To conclude, eVPN will resolve critical limitations that we have in the traditional VPNs. The evolution requires planning of services, of topology, and of protocols, and most of all, training of the team. All the things that we suffered from MPLS, in the case of VPN, we also need to do capacity building. The migration solutions are flexible, as I showed. We have internetworking to hierarchical networks, and then for solutions for non-hierarchical networks. And we have real cases that Nick didn't show this, but Nick is showing examples of the IX in Brazil with the implementation of eVPN and all the benefits that the IX.BR is having in the IX of Sao Paulo. We had terrible problems with the broadcast, and eVPN is helping us find solutions to this. To close, here you have a book if you wish to check this out. This was launched at the beginning of this year and my presentation includes much of the things contained in that book. If you wish to expand your knowledge, this doesn't speak about commands, although this is a Huawei book. It doesn't speak about any device at all. It just refers to the protocols and the migration process. So this is just a recommended reading. I will be around if you have any questions. Thank you, Luis. Thank you. So with this, we close this.